Hi, my name is Christian Sarowski and I'll be demonstrating to you my fourth year project on procedural generation within roguelike games. I made the project in Unity and I'll be demonstrating it in the editor view so that we can see the full view of the levels generated within the game. So the project starts off within the main menu scene from which we can access the stats screen, which compares the top-down approach versus the bottom-up approach and the gameplay itself. When we press play, we can either select the top-down approach, which uses recursive subdivision, or the bottom-up approach, which uses a minimal spanning tree. So when I select the top-down approach, in the gameplay manager, we can see the generation type that has been selected, which is the top-down. This is stored in the gameplay manager, which is a singleton object, which means it maintains between scenes within Unity, allowing us to use the correct generation type as well as the seed, keeping it the same between each of the scenes, i.e. levels, within the game. Thus meaning that the level, if we put in the seed, again, will be exactly the same. We then get the option to select either a random or a custom seed, which can be up to 6 characters. When we select a random seed, it uses one of the letters or numbers from the string randomly until it has 4 characters selected. So when I press random, we use a random seed, which is displayed to the player in the top right, and on the very right we can see that it is in the gameplay manager. This is then used by the level manager, which in the case has a level width and a height of 60 by 60 and number of rooms to place of 12. And thus it stores these parameters and then calls the gameplay manager to select the generation type and calls each of the functions in the correct order to generate the 2D level, place down all the rooms, generate the mesh, and then place down enemies, power-ups, and shopkeeper, etc. And thus, here we are going to be using the top-down approach, which we can see the level that it has generated using recursive subdivision. So the top-down generation starts off with the grid area, which is basically initially the entire level area that then slowly gets divided into smaller and smaller sections. The map grid is the actual grid itself, which are the tiles. Either it's a wall, node, wall, empty, which is where the player can walk, inner wall, which is basically the same as the wall, but just lower, and the exit, which we use then later on for the connection. So we recursively call the function place room layout, which attempts to place the room within itself, or one of the child nodes if they are bigger than the current room they're storing and the new room that has to be placed within the grid area that will be then split into half, or if either one of the rooms is bigger than a half, it's spread. It's cut proportionally, and thus we call this function recursively, attempting to initially place down the room on the side which has less children. So if the left side has 3 and the right side has 2, it will first try to place it on the right side. If it fails, it will go then to the left side. And we'll continue this process until the room has been placed successfully, or we just ran out of options where to place it, and this runs for all the rooms within the list until we've gone through all of them. The room layouts are then transferred onto the grid of the map. This is due to the fact that room layouts have their own smaller interior grid, which then they transfer into the correct locations within the map itself. The size of the rooms is generated using the seed between the 7 and 15, and we'll say the same if we rerun this using the same seed. Once all of the rooms have been placed, the binary tree that has been created is then used to connect the rooms together. And thus, the way it is done, it connects goes to the bottom of the tree and starts with connecting the closest rooms on the left nodes with the closest rooms on the right of the nodes, and it selects the 2 that are closest and just keeps connecting them until there's at least one connection between each of the left and right side nodes. which we can see this resulted in this. The corridors itself are then created between the rooms using a style algorithm to just travel the tiles in between the rooms. The resulting 2D grid is then put into the mesh generator, which uses the marching squares algorithm, which I'll be demonstrating in a second. Thus, if I back out and press play, we will now generate a level using bottom up and once again a random seed. So we can see the level layout is much different than the previous one, and we can see that the generation is bottom up and the seed is different. Thus, if we go into bottom up generation, the rooms are placed randomly within the grid. Each time we validate if the room can be placed, and we attempt this until we have tried sufficient number of times, or we've managed to place all the rooms, whichever happens first. The rooms are then connected together by creating tile arcs between them. These arcs are just created by traveling in the horizontally and vertically through the grid and connecting the rooms if they have and creating arcs between rooms if they don't have arcs between each other, as long as there's no other room indescribably between them. For example, this room gets connected to this one and to this one with the arc, but is not connected to that one, as we can't access it in a straight line because this one's blocking it. And thus the tile arcs between the rooms are then used to create the minimum spanning tree, for which I use Prim's algorithm that just connects the rooms together using the shortest arc, starting at the initial room, which is the room in which the player spawns. The last room that has been placed as well is always the boss room, which does not have to be the furthest one from the starting room, but is the last one that has been placed. And thus, if I back out and I press play again and I use the custom seed, if I type in demo 04 and hit confirm, we can see the room layout that has been generated using the top down. And if I back out again and do the same thing again, top down, custom seed, I type in demo 04, we can see that the room layout is exactly the same. This is because of the procedural generation, meaning that if once it's seeded, it will be always the same. The mesh that we see of the inner walls, which are these brown walls in front of the player, and the outer walls is created using the marching squares algorithm, which we can see here. If we click on the level manager, we can see that the mesh generated is then used as a collider for the player later on. This mesh is generated using the marching squares, which starts off with passing the tile grid and then converts it to squares that are composed of triangles. And these triangles are composed of minor and major vertexes. The major vertexes being the actual nodes themselves, meaning the center of the tiles, and the minor ones are the halfway points between them. Each of them takes control of the top and the right vertexes. And for my case, because I am running this to make sure that the rooms stay square-like rather than cutting corners, as marching squares algorithm likes to basically just cut the corner at the halfway point, I create the center minor node, which I call top right, which basically then allows us to maintain the 90-degree angle structure, especially for corridors, as they would normally cut the line and make them straight at these intervals. Each of the squares generated for the marching squares is triangulated using the configuration of the active vertices, meaning the active vertex in this case is a wall or an inner wall, as I run this twice for the outer and the inner walls to allow them to be different height, passing obviously the height of the wall itself. The most important configuration are these, which are the 3-corner configurations, as these require extra squares to be made, as basically it would mean we would cut corners otherwise, and thus we need to make those extra ones to allow us to maintain those 90 degrees angles. Once the top, so the ceiling of the walls has been created. It then creates the wall by simply extending the walls down by following the outline of the mesh, checking if it's an outline by simply seeing how many how many triangles is it bordering. If the outline is not bordering more than one triangle, then it extends down, making the walls that you can see within the game. These walls have then a texture applied to them, which I scale to match the number of basically triangles that has been extended down, as it is the solution that I found to work relatively well. So now I will go into the gameplay. So I'll just back out and make this full screen. I'll press play, press top down, use the custom seed demo 04. And thus we can see in the top left the player's health and the gold they have. For the purpose of the demo, I have set the gold of the player to be much higher, so I can demonstrate the items that have been purchased. Initially, the player is very slow to allow enemies to chase him, and as we can see, we have entered a power-up room, which spawns a pickup that is then applied to the player. These pickups are stored in a JSON file to be able to be read at the start of each level, so that they persist between levels. So once I pick it up, we get a speed boost. I have made this a bit stronger for the purpose of the demo. Here we can see an enemy moving around the room and firing projectiles at the player. They use raycasting to basically detect, and once we hit them, they create particle systems, such as this one, which is also gold particle system, and the same for the fireball, which is a particle system itself. The enemies try to attack you from a distance, or if you get too close, they try to charge at you. So once I kill all the enemies in the room, this will allow us to exit the room as we are currently locked. So once I get the last one, it is running away from me. We unlock the room and we spawn the shopkeeper. For the purpose of the demo, I have set the shopkeeper to spawn in each combat room. So once we access it, we can see the shop. The shop loads this data from a JSON file, and basically selecting, loading in all the options, and then selects 5, which will stay the same in this particular shop. So if I press this, I have purchased a shotgun and I can no longer buy it. And I'll purchase a damage up. So once I press on this, it stays sold, and I can't interact with these, as well as I don't have enough gold, so I can't buy the attack speed. So I'm going to buy the speed, movement speed buff, and we can see that we are much faster. So once I enter this room, I am once again trapped, and I need to kill all the enemies. I have now a shotgun, which deals a lot of damage, firing a number of pellets, and is especially effective at close range. And once again, you see a shopkeeper spawn, and if I interact with him, we're able to see that he offers different items that we can purchase from him. So I will just purchase the heal, and as we can see, the health went back up. And now we'll be entering the boss room. Sorry, one more. We have picked up the attack speed boost, which is applied to the player and will be maintained between levels. And now we will enter the boss room. So the boss has 5 different stages which he moves through. So we've been in a relatively short distance, so he tried to attack, charge at us. Now he will fire projectiles, and he will most likely go to the charge attack after a few of the shots. These shots explode and deal a lot of damage to the player. For the purpose of the demo, I've set the boss's health to 1, so if I shoot him, he just instantly dies. And this is the portal, which we then use to jump through and go to the next level. As we can see, our health persisted, our movement speed also persisted, and our weapon persisted. And thus, we will return now, lastly, to the stat screen. So, once we click on the stat screen, we can see that the we can see the parameters for the generation. So I'll just generate a maximum size map with a number of 40 rooms, and I'll more or less do 5 generations. So now press play. We will see the grids that have been generated, and after a shorter period of time, the bottom up will start, and then the top down will run, showing the average time, the longest time run, then rooms placed, on average, least, and most. This data is then saved to a JSON file, which we can see here, and it can be used to check basically the generations times and number of rooms for each of the approaches over a number of runs. So that is my entire project. I hope you liked it, and if there's any more questions, feel free to reach out to me.